Assalamu alaikum dear students. Welcome to App6 online support program for mathematics class 8 week 13 prepared by Amna Ghaffar. Textbook Caravan Mathematics book Unit 2 Real and Complex Number Topic Complex Numbers Exercise number 2.5 Resources required laptop, internet, textbook and notebook. Objectives: student will be able to define complex number, recognize real and imaginary part, define conjugate of complex number. Previous knowledge: number system. Number system consists of different set of numbers such as natural numbers. The set of natural numbers is denoted by capital N and it starts from 1, 2, 3 up to so on. Whole numbers: if we include 0 in the set of natural number, the resulting set is the set of whole numbers denoted by capital W. From this set of numbers, it is clear to all that n is the proper subset of W. It means all the elements of n are present in W and n not equal to W. Integers. The set of integers consists of positive integers 0, negative integers and it is denoted by capital Z. N is the proper subset of W. N and W is a proper subset of Z. Rational numbers. Rational numbers expressed in the form P by Q, where P and Q are integers and Q not equal to 0. Natural number, whole numbers, integers are the subset of rational numbers. Irrational numbers. Irrational numbers cannot express in the form P by Q. The union of the set of rational numbers and irrational numbers is known as the set of real numbers. It is denoted by capital R. That is, the set of real numbers is equal to the set of rational numbers union the set of irrational number. Here is the Venn diagram of the set of numbers. Natural number is a subset of whole number. Natural numbers, whole numbers are the subset of integers. Natural number, whole number, integer are the subset of rational numbers. When we combine rational numbers and irrational number, the new set of numbers form that is called real number. Note: rational numbers and irrational numbers are disjoint set. Disjoint sets mean they have no common elements. All numbers that can be represented on number line is called real numbers. This is a number line. I am going to circle the positive numbers on number line. The square root of all positive numbers are real numbers. As we all know that real numbers are formed when we combine rational numbers and irrational numbers. For example, the square root of all positive perfect squares are rational numbers such as under root 1, under root 4, under root 9, under root 16, under root 25 up to so on. These numbers are rational numbers. For example, the square roots of all positive prime numbers and non-perfect squares are irrational numbers such as under root 2, under root 3, under root 5, under root 6, under root 7 up to so on. These numbers are irrational numbers. When we combine rational numbers and irrational numbers, then real numbers are formed. I am going to circle the negative numbers on number line. Is the square root of all negative numbers are real numbers? No, because under root minus 1, under root minus 2, under root minus 3 up to so on does not exist in real numbers. If under root minus 1, under root minus 2, under root minus 3 up to so on does not exist in real numbers, then which type of numbers are these? Such numbers are called imaginary numbers. The Swiss mathematician Leonhard Euler was the first to use the symbol iota for the number under root minus 1. Iota equal to under root minus 1. If we take the square on both sides, then iota square equal to minus 1. Therefore, under root minus 1 is equal to iota. Under root minus 2 equal to, we can write under root minus 2 as under root 2 into minus 1. Apply under root on both numbers, so under root 2 into under root minus 1, under root 2 and under root minus 1 is equal to iota. Under root minus 4, we can write under root minus 4 as under root 4 into minus 1. Apply under root on both numbers, so under root 4 into under root minus 1, under root 4 is equal to 2 and under root minus 1 is equal to iota. In this exercise, we are going to discuss complex numbers. When we combine the real and imaginary numbers, then complex number is formed. Real number plus imaginary number equal to complex number. A complex number is a number that can be expressed in the form of a plus b iota, where a and b are real number and iota equal to under root minus 1 is an imaginary number. It is denoted by small z. In this expression, z equal to a plus b iota. Here, the real part of z equal to a and imaginary part of z equal to b. Exercise 2.5. Question number 2. Write the real and imaginary part of the following numbers. First part, 1 plus iota. The real part of complex number equal to 1 and the imaginary part of complex number equal to 1. Part 2, minus 1 plus 2 iota. The real part of complex number equal to minus 1 and the imaginary part of complex number equal to 2. Part 3, minus 3 iota. The real part of complex number equal to 0 and imaginary part of complex number equal to minus. Either part can be 0. All complex numbers have the form a plus b iota, where a and b are real numbers. A is the real part of the complex number and b is the imaginary part. Z equal to a plus b iota. If b equal to 0, put b equal to 0 in the complex number, so we get z equal to a plus 0 iota, which is equal to z equal to a. Then a is called a real number. Z equal to a plus b iota. If a equal to 0, put a equal to 0 in complex number, then z equal to 0 plus b iota. Z equal to b iota, then b iota is called a pure imaginary number. Z equal to a plus b iota if a equal to 0 and b equal to 0, then z equal to 0 plus 0 iota. So, this is the Venn diagram of the number system. When we combine real numbers and imaginary numbers, then new set of numbers are formed that is called complex number. Note, every real number is a complex number, but every complex number is not a real number. Complex conjugate. To find the conjugate of complex number, we change the sign of the imaginary part. Complex conjugate is denoted by z bar. Exercise 2.5, question number 2. First part, complex number is given z equal to 5 minus 3 iota. We want to find conjugate of the complex number, then z bar equal to 5 plus 3 iota. We only change the sign of the imaginary part, so the conjugate is 5 plus 3 iota. Part number 2, z equal to 4. We can also write as z equal to 4 plus 0 iota. Now the conjugate of the complex number is z bar equal to 4 minus 0 iota, which is equal to z bar equal to 4. Part number 3, z equal to 6 iota. We write as z equal to 0 plus 6 iota. The conjugate of the complex number is z bar equal to 0 minus 6 iota, z bar equal to minus 6 iota. Integral exponent of iota. By using iota equal to under root minus 1 and iota square equal to minus 1, we can easily calculate the integral exponent of iota. Exercise number 2.5, question number 1. If the iota exponent is even, then split iota exponent in the form iota square whole power n. For example, iota power 12. 12 is even, then split in the form iota square whole power 6. As we all know that iota square equal to minus 1. So minus 1 whole power 6 mean multiply minus 1 by itself 6 times. So it is equal to 1. If iota exponent is odd, then split iota in iota exponent even into iota exponent odd. For example, iota power 7. 7 is odd, then split into iota exponent even into iota exponent odd. So iota power 6 into iota power 6, we can write iota power 6 in the form iota square whole power 3 into iota. We all know that iota square equal to minus 1. So minus 1 whole power 3 into iota, minus 1 into iota, which is equal to minus iota. So when the iota exponent is even, then its simplest form must be real number. When the iota exponent is odd, its simplest form must be a imaginary number. Equality of complex numbers. Two complex numbers are said to be equal if and only if their corresponding real parts and imaginary parts are equal. That is, z1 equal to z2, a plus b iota equal to c plus d iota. Now compare their real parts and imaginary part. So we have a equal to c and b equal to d. Exercise 2.5, question number 4. Find the value of x and y if x plus y iota plus 1 equal to 4 minus 3 iota. Solution: x plus y iota plus 1 equal to 4 minus 3 iota. On left hand side, first we will arrange real and imaginary parts. So x plus 1 plus y iota equal to 4 minus 3 iota. Corresponding real part and imaginary part. X plus 1 equal to 4 and y equal to minus 3. To find the value of x, shift plus 1 to the right side of the equation. So x equal to 4 minus 1, x equal to 3. Therefore, the value of x equal to 3 and y equal to minus 3. Written work, exercise number 2.5. All written work to be done on notebook with proper date mentioned on the top. Thank you, class.